Okay, and the last one we're going to take a look at here is f of x is equal to x squared plus x minus 2 divided by x plus 1. Let's start by finding the domain. We set the denominator equal to 0 and we solve it and we get x is equal to negative 1. Now that's the number I've got to leave out of the domain. So if I were going to write the domain, we'd write negative infinity to negative 1 union negative 1 to, negative 1 to infinity, right? Everything else except for negative 1. Remember the vertical asymptotes, just that x value that you found when you solved it, x is equal to negative 1. Removable discontinuities. To be able to find a removable discontinuity, I've got to factor the numerator. So one thing we want to do is, at this point, it's pretty smart for us to go ahead and factor the numerator. X squared plus x minus 2. How could we factor that? Well, I'm looking for numbers that multiply up to negative 2 and add up to 1. I think it would be x minus 1 and x plus 2 over x plus 1. Removable discontinuities. We were really close here, but none of these factors match up, so there are going to be no removable discontinuities. Horizontal asymptotes. That's where we look at the Let me back this up. This is x is equal to negative 1, right? That is our vertical asymptote. Let's go back and let's actually draw that vertical asymptote in. We know we're going to have that vertical asymptote here at x equals negative 1. All right, horizontal asymptotes. This is where we look at the degree of the numerator and the degree of the denominator. The degree of the top one is 2. The degree on the bottom one is 1. So there is no horizontal asymptote, but we are in that special case where we're going to have a slant asymptote. So to be able to find that horizontal asymptote, let's actually do some polynomial long division. I know you guys were dying to do this. So x squared plus x minus 2, and we're going to put our x plus 1 on the outside. And I have an x, I want to get to an x squared, so we're going to multiply that by an x. X times x is x squared. X times 1 is positive 1x. And then remember, we need to flip those signs, so this becomes a minus, and that also becomes a minus. And now we're going to combine the terms. So x squared minus x squared cancel out. 1x minus x is going to also cancel out, brings down this minus 2. This is it. I can't multiply something by an x to get a negative 2. So we actually have a slant asymptote at y is equal to x. I know what that's going to look like. It's like an identity function. So it's going to look like this. It's going to be that it's going to have a slope of 1, right? And it's going to go through the origin. So there's that. X-intercepts, this is where you set the numerator equal to 0. So when I do that, I'm going to actually use the factored form. We're going to set these equal to 0. So I'm going to get x minus 1 equals 0, which is going to give me x equals 1. So I know I've got an x-intercept right here at 1. Sorry, it's not liking me drawing this dot. There's my x-intercept there. And then I have another intercept at x equals, well, we're going to do x plus 2 equals 0 minus 2. I get x equals negative 2. So I also have an oblique asymptote here. Y-intercepts, we plug in a 0 for x. So it's going to be 0 squared plus 0 minus 2 over 0 plus 1, which is going to give me negative 2 over 1, which is negative 2. So I know my y-intercept is down here at negative 2. This is kind of vibing with like what I think this graph is going to look like. So if I was to draw this graph, I'm just going to assume it looks something like this, and then I will put it into the graphing calculator, and we will see if this matches up. And when I take a look at this, I'm going to put this, you can see I have that in here, and when I zoom out on this graph, we can see it does look pretty similar to, much nicer than this one I drew right here. Oops, sorry about that. And, sorry, let me get back to where we were. And one other thing I want to show you is I had that oblique asymptote at y equals x. And if I draw that, you can see it does follow along that horizontal line.